Germany didn't run out of soldiers. It didn't run out of steel. It didn't even run out of factories. What Germany ran out of was electricity. On a cold night in late 1943, deep inside the industrial heart of the Ruhr, engineers watched gauges sink into the red as demand exceeded anything the grid could supply. Power stations screamed under impossible loads. Turbines strained. And in that moment, a truth became unavoidable. The war economy was dying not from bombs, not from invasion, but from a system pushed beyond physical limits. Tanks, planes, U-boats, railways, radios, every weapon of modern war depended on one invisible force. When that force failed, the entire machinery of the Reich began to go dark. And once the lights started going out, no army on earth could save it. In the mid-1930 seconds, Germany believed it had solved the problem of modern industry. Its electrical grid was among the most advanced in Europe, dense networks of coal-fired power plants in the Ruhr, hydroelectric stations in the south, transmission lines feeding cities, factories, and rail hubs. To civilian planners, it looked sufficient. To politicians, it looked impressive. But beneath the numbers was a quiet assumption that would later become fatal. The system had been designed for peace. When Adolf Hitler announced the four-year plan in 1936, Germany's economy was ordered to transform at a speed no industrial nation had ever attempted. Steel production surged. New aircraft factories appeared almost overnight. Tank assembly lines expanded. Railways ran longer hours. Communications networks multiplied. Every lever of the economy was pulled at once. And every single one of those levers drew electricity. At first, the strain was invisible. Power stations compensated by running longer shifts. Engineers pushed turbines harder. Maintenance schedules were quietly relaxed. The grid bent, but it did not break. To Berlin, this looked like success. Rearmament numbers climbed. Factory output charts went up and to the right. The illusion took hold that industrial willpower could override material limits. But electricity does not respond to ideology. By 1938, Germany's power generation was already operating near its ceiling. New plants were proposed, but they required steel, copper, turbines, skilled labor, and most critically, time. All of those were being diverted to weapons production instead. Every megawatt added to the grid meant fewer guns, fewer tanks, fewer aircraft. Faced with that choice, the regime always chose weapons. No one wanted to be the man who told Hitler that the lights mattered more than the guns. Inside power stations across the Ruhr, engineers began seeing warning signs, load curves that never dipped, frequency fluctuations that hinted at instability, equipment wearing out years ahead of schedule. These were not dramatic failures, just small deviations, easily dismissed, quietly logged, and politically dangerous to emphasize. Germany was building a war machine that demanded more energy every month, while the system feeding it remained almost static. By the time war broke out in 1939, the Reich had locked itself into a trap. The factories that symbolized German strength were already consuming electricity faster than the grid had been designed to supply. The only thing holding the system together was overwork, deferred repairs, and the hope that victory would come before the bill arrived. That bill was already accumulating, and it would come due long before the bombs began to fall. The electrical crisis stopped being theoretical the moment Germany tried to solve its fuel problem. Germany had oil shortages long before the war began. Imports were vulnerable. Blockades were inevitable. To Adolf Hitler, dependence on foreign fuel was a strategic nightmare. The solution, on paper, looked brilliant. Synthetic fuel. Turn coal into oil. Power tanks, aircraft, trucks, and submarines without relying on imports. What the planners underestimated was the price. Synthetic fuel plants were not just factories. They were chemical monsters. Massive hydrogenation towers, compressors running day and night, high-pressure reactors that consumed electricity at levels unheard of in conventional industry. Producing fuel this way didn't save energy, it devoured it. By the early 1940 seconds, Germany's synthetic fuel network had become the single largest drain on the national electrical grid. Inside facilities like Leuna and Merseburg, electricity flowed not into weapons, but into the ability to make fuel for weapons. Every barrel of synthetic oil required staggering amounts of power. Engineers knew the numbers. Power station managers saw the draw. Quiet internal estimates suggested that by 1942, a quarter to a third of all electricity in Germany was being consumed just to keep synthetic fuel production running. The war economy had entered a loop. Electricity was needed to make fuel. Fuel was needed to generate electricity. Both were needed to build weapons. There was no surplus anywhere in the system. When Albert Speer took control of armaments production in 1942, he inherited this contradiction fully formed. Speer was not ignorant of technical systems. He understood bottlenecks. He understood throughput. He understood that factories were being throttled not by labor or raw materials, but by power. Yet, even Speer could not solve the central problem. You cannot conjure megawatts out of administrative efficiency. Building new power plants would take years. They required turbines, copper windings, transformers, skilled labor, all of which were already rationed to weapons programs. Diverting resources to energy meant slowing armaments output immediately. In a regime obsessed with production figures and battlefield momentum, that choice was politically impossible. So the system was pushed harder instead. Power plants ran continuously. Safety margins vanished. Maintenance became emergency repair. Engineers were ordered to make it work, even as they watched equipment age in months instead of years. The grid was no longer operating, it was being consumed. At the same time, Germany expanded its war geographically. New territories meant new factories, new rail lines, new demands. When the Reich pushed eastward and captured Soviet power facilities, planners briefly believed the crisis might ease. It didn't. Retreating forces had destroyed much of the infrastructure. What remained was incompatible, damaged, and far from where German industry needed it most. Integrating these systems took time Germany no longer had. Within months, the same shortages returned, unchanged, unsolved. By 1943, the illusion was gone for those close to the system. Engineers knew the grid was maxed out. Factory managers knew production schedules were lying. Administrators knew that every new weapon order meant another sector would go dark. But the information didn't travel upward. In Nazi Germany, bad news was not rewarded. It was punished. So, the electrical crisis remained officially unspoken, while silently tightening its grip around every factory, every rail hub, and every weapons program in the Reich. And then the Allies began aiming not at factories but at the power itself. The turning point came when the Allies realized something Germany's own leadership still refused to face. Factories were not the real target. Electricity was. By 1943, Allied planners had absorbed a hard lesson from earlier bombing campaigns. Destroying individual factories produced impressive photographs but limited results. Production could be dispersed, repaired, or restarted. What could not be easily replaced was the invisible system that powered all of them. The electrical grid was the war economy's circulatory system. If it failed, everything failed at once. That summer, the bombing strategy changed. Instead of chasing individual weapons plants, Allied bombers began hitting power stations, substations, transformer yards, and transmission nodes, targets few civilians noticed, but every factory depended on. The most dramatic demonstration came in Hamburg. In late July 1943, incendiaries and high explosives combined to create a firestorm that consumed the city. Tens of thousands died. But beyond the human catastrophe was an industrial one. Hamburg's electrical infrastructure was crippled. Major power plants were knocked offline. Transmission lines collapsed. Substations burned. Across northern Germany, factories went dark almost simultaneously. Assembly lines stopped mid-shift. Machine tools froze in place. Rail yards fell silent. Weapons production didn't slow, it ceased. Not because workers were dead or buildings destroyed, but because electricity was gone. And electricity could not be rerouted fast enough. Germany's grid lacked redundancy. It had been built for efficiency, not resilience. Major node failed. Entire regions lost power. Repairs required transformers, copper, skilled crews, and time, all of which were now under constant air attack. From that point on, the electrical crisis was no longer theoretical or hidden. It was visible, measurable, and accelerating. By 1944, Allied bombers focused heavily on synthetic fuel plants not only because fuel mattered, but because these facilities were electrical black holes. Every damaged plant created two crises at once: less fuel and wasted electricity diverted into a broken system. The effect cascaded. Less fuel meant fewer trains. Fewer trains meant coal didn't reach power plants. Less coal meant less electricity. Less electricity meant factories shut down. Each failure reinforced the next. German engineers tried desperate measures. Power was rationed by the hour. A factory might receive electricity for a few hours, produce as much as possible, then go dark so another facility could briefly operate. Efficiency collapsed. Machines hate being stopped and started. Output plunged even where buildings still stood. The military felt the impact immediately. Shipyards could not finish submarines. Aircraft plants could not maintain engine tolerances. Rail networks failed to move units at scale. Advanced weapons existed on paper, but the grid could no longer support their production. By the winter of 1944, Germany was no longer fighting a war of attrition against enemy armies. It was fighting a war against arithmetic. Every day, demand exceeded supply. Every repair took longer than the damage that followed. Every decision about electricity meant choosing which part of the war effort would die next, and there were no good choices left. The bombs had not destroyed Germany's war economy in one blow. They had removed the power that kept it alive. From that moment on, the outcome was no longer a question of strategy or courage. It was a countdown. Why late? 1944. The electrical crisis stopped being an industrial problem and became a battlefield one. Germany still had soldiers. It still had factories. It still had designs for advanced weapons. What it no longer had was continuous power. Inside the Reich, electricity was now rationed like food. Power authorities issued schedules deciding which factories would run and which would go dark. A tank plant might receive electricity for 6 hours, then shut down so an aircraft factory could operate for 4. Submarine yards lost power so rail lines could function. Cities were blacked out not for air defense, but because there was nothing left to distribute. Production became fragmented and inefficient. Machines designed for constant operation were repeatedly shut down and restarted, destroying tolerances and output rates. Skilled workers stood idle beside intact equipment, waiting for the lights to come back on. Entire shifts were wasted not by bombing, but by silence. This was the environment in which Germany attempted its last great gamble. In December 1944, Hitler launched the Battle of the Bulge. On paper, it was bold. In reality, it was electrically impossible. Tanks required fuel. Fuel required synthetic plants. Synthetic plants required electricity. None of those links were intact anymore. German units entered the Ardennes already rationed. Tanks stalled, not because of enemy fire, but because fuel trucks never arrived. Rail lines feeding the front failed repeatedly due to power outages. Communications broke down as electrical systems faltered. The offensive collapsed not under Allied brilliance but under logistical paralysis. The same story repeated across the armed forces. The Navy had submarines sitting in pens that could not sail. Shipyards lacked power to finish engines and batteries. Even completed boats often remained idle. There was no fuel to justify deploying them. The Air Force faced an even crueler irony. Germany possessed the most advanced jet fighter of the war. But jet engines demanded precision manufacturing, stable power, and enormous electrical input. Factories could not sustain production runs. Pilots could not be trained. Fuel and electricity were both rationed. The weapon arrived too late, too slowly, and in numbers too small to matter. By early 1945, the crisis had turned grotesque. Power engineers received demands that exceeded the entire national capacity. When they failed, they were accused of sabotage. There was no sabotage, only mathematics. You cannot generate electricity you do not have. You cannot distribute power through shattered lines. You cannot fight modern war in the dark. The electrical grid had become the final bottleneck, one no heroism could overcome. As Allied armies closed in from west and east, Germany's war economy wasn't just damaged, it was intermittent. A nation fighting by flickering light cannot sustain mechanized warfare, and the flickering was about to stop entirely. By the spring of 1945, Germany's electrical system no longer functioned as a grid. What remained were isolated pockets of generation-damaged power plants producing electricity that often couldn't be transmitted anywhere useful. Transmission lines were cut, substations were destroyed, switching yards were rubble. Even when turbines still turned, the power died close to the source. Cities went dark for reasons that had nothing to do with air raids. Factories that had survived years of bombing stood intact but useless. Assembly lines froze permanently. Rail networks failed as signaling systems lost power. Communications collapsed not because wires were cut, but because there was nothing left flowing through them. The war economy didn't end in an explosion. It ended in silence. Engineers across Germany knew the truth before politicians admitted it. The system was finished. There was no recovery curve, no emergency fix, no reserve capacity left to draw upon. Electricity, the foundation of modern warfare, had fallen below the minimum required to sustain the state. Even if the fighting had stopped overnight, weapons production could not have resumed. In Berlin, as Soviet forces closed in, the last power stations shut down or were destroyed. Government offices operated by candlelight, telephone exchanges failed, transportation stopped. The capital of the Reich surrendered in near total darkness. Not metaphorically, literally. Germany had entered the war believing that willpower, organization, and speed could overcome material limits. The electrical crisis proved the opposite. No ideology can override physics. No amount of courage can replace megawatts. No military brilliance can function when the infrastructure beneath it collapses. The Allies did not just defeat Germany's armies, they exhausted the system that fed them. And that is why the war ended the way it did, not only with tanks in the streets and flags over ruins, but with the quiet realization that the lights were never coming back on. Germany did not lose World War II in a single battle. It lost it the moment its electrical grid crossed a line it could never return from. One of the most persistent myths of World War II is that victory is decided primarily by armies clashing at the front. In reality, battles are downstream events. They reflect decisions made years earlier in factories, power plants, transport networks, and planning offices. Germany entered the war with formidable armed forces, advanced weapons designs, and a population mobilized for sacrifice. What it did not have was an energy system scaled for total war. Electricity powered everything: steel mills, chemical plants, rail signaling, communications, shipyards, aircraft factories. Once the electrical grid reached its ceiling, every other part of the war effort became fragile. This exposes a hard truth. You cannot fight a modern war without excess energy capacity. A system designed to operate at or near 100% in peacetime will collapse under wartime stress. Wartime systems require redundancy, slack, and resilience, not just efficiency. Germany optimized for speed and output, not sustainability. That choice shaped the entire war. Ideology cannot override physics. Authoritarian regimes often believe that willpower can overcome material constraints. Nazi ideology was especially hostile to the idea of limits, admitting that something as mundane as electricity could constrain Germany's destiny was ideologically unacceptable. But physics is indifferent to ideology. Electricity generation is governed by hard realities: turbine capacity, fuel supply, transmission limits, maintenance cycles. No speech, no decree, no purge can change those facts. Germany tried to substitute political pressure for physical capacity, and the result was predictable. Power plants were run beyond safe margins. Maintenance was deferred. Equipment aged rapidly. Failure became cumulative. The lesson here is timeless. Systems collapse when leaders treat technical constraints as political obstacles rather than physical facts. Efficiency without resilience is a trap. Germany's pre-war electrical grid was efficient by European standards. It delivered power where it was needed, with minimal redundancy and high utilization. In peacetime, that efficiency looked like strength. In wartime, it became a liability. When Allied bombing began targeting power stations, substations, and transmission lines, the grid had little capacity to absorb damage. There were few alternate routes, limited spare transformers, and insufficient repair resources. A single hit could black out an entire industrial region. Resilience, redundancy, zapas, capacity, decentralization always appears wasteful before a crisis. During a crisis, it becomes decisive. Germany learned too late that systems optimized for efficiency tend to fail catastrophically under stress. Strategic choices compound over time. The electrical crisis did not suddenly appear in 1943 or 1944. It was the result of decisions made as early as 1936. Germany chose rapid rearmament over long-term infrastructure expansion. It chose weapons output today over energy capacity tomorrow. Each choice made sense in isolation. Together, they created a trap. Once the war began, Germany no longer had the time, materials, or strategic freedom to fix the underlying problem. Building new power plants takes years. Expanding grids requires copper, steel, skilled labor, and stability. War destroys all four. This highlights a crucial lesson. Early strategic decisions shape the range of options available later. Systems fail, not because of one mistake, but because of long chains of rational choices that ignore cumulative risk. Synthetic fuel revealed the danger of self-reinforcing loops. Germany's synthetic fuel program is a textbook example of a self-reinforcing systemic failure. The program was designed to solve fuel shortages. Instead, it created an energy sink so large that it accelerated grid collapse. Electricity was consumed to make fuel. Fuel was needed to generate electricity, and both were needed to produce weapons. There was no surplus anywhere in the loop. Once bombing disrupted any part of this cycle, the entire system unraveled. Power shortages reduced fuel output, fuel shortages reduced power generation, production collapsed even where factories were undamaged. The lesson is clear. Complex systems with circular dependencies are extremely fragile under stress. When every component depends on every other component, failure propagates instantly. 6. Administration cannot substitute for capacity. Albert Speer is often praised for increasing German armaments output despite Allied bombing. And in relative terms, he did improve efficiency. But efficiency gains are not the same as capacity expansion. Speer could streamline production, rationalize supply chains, and reduce waste. He could not create megawatts. No administrator, no matter how competent, can produce energy without physical infrastructure. This distinction matters far beyond history. Modern societies often mistake managerial competence for systemic strength. But when systems reach physical limits, management becomes irrelevant. You cannot organize your way out of an energy shortage. The Allies won by attacking systems, not symbols. Early bombing campaigns focused on factories, cities, and visible industrial targets. Results were mixed. The decisive shift came when the Allies recognized that electricity was the system beneath all others. Power plants, substations, and transmission lines were not glamorous targets. They did not produce dramatic explosions or immediate battlefield effects. But they created cascading failure. One blackout stopped dozens of factories simultaneously. This reflects a broader strategic insight. The most effective targets in complex systems are often the least visible ones. Destroying the nodes that coordinate and energize systems is more powerful than destroying individual outputs. Late war weapons don't matter without infrastructure. Germany produced advanced weapons late in the war. jet aircraft, new submarines, improved tanks. These are often cited as evidence that Germany could have won if circumstances were different. But advanced weapons are infrastructure dependent. Jet engines require precision machining, stable power, and extensive testing. Submarines require powered shipyards, battery production, and fuel. Tanks require steel, transport, and maintenance networks. Without electricity, advanced weapons remain prototypes. The lesson here is brutal. Technology cannot compensate for systemic collapse. Innovation at the edge is meaningless if the foundation is gone. Infrastructure failure turns military defeat into inevitability. By late 1944, Germany's defeat was no longer primarily military. It was mathematical. Demand for electricity exceeded supply every day. Repairs took longer than damage accumulation. Choices became zero-sum. When a system reaches that point, outcomes are no longer negotiable. Courage, tactics, and sacrifice can delay collapse, but they cannot reverse it. This is one of the most sobering lessons of the war. There is a stage of systemic failure beyond which recovery is impossible, regardless of effort. Modern societies remain vulnerable in the same way. It is tempting to view Germany's electrical collapse as a historical anomaly. It is not. Modern societies are even more dependent on electricity than Germany was in the 1940 seconds. Today, electricity powers food, production, and refrigeration, water treatment and distribution, healthcare systems, communications and data networks, transportation and logistics. The lesson is not merely historical, it is contemporary. When energy systems fail, everything else fails with them. And because these systems are often invisible during normal operation, they are systematically undervalued until crisis strikes. 7. The most dangerous failures are quiet ones. Germany's electrical crisis developed in silence. Engineers knew, power station managers knew, mid-level administrators knew, but the system discouraged bad news. Problems that could not be solved politically were ignored politically. This is perhaps the most universal lesson of all. Systems fail fastest when organizations suppress inconvenient truths. The blackout did not arrive as a surprise. It arrived as an unspoken certainty. War exposes the truth about societies. In the end, Germany's electrical collapse revealed something deeper than technical miscalculation. It revealed how the regime understood power itself. Germany believed power came from will, discipline, and obedience. The Allies understood that power came from systems, energy, logistics, production, coordination. One worldview ran into physics, the other worked with it. Wars do not just test armies, they test assumptions about how the world works. Germany lost because its assumptions were wrong. Conclusion. Germany did not lose World War II solely because of enemy armies, strategic blunders, or moral failure, though all played a role. It lost because it tried to sustain a modern industrial war on an electrical system that could not support it. Once the grid failed, defeat was inevitable. The deeper lesson is not about Germany. It is about systems, about limits, about the danger of mistaking intensity for capacity, ideology for physics, and short-term output for long-term resilience. Modern power does not come from shouting louder or working harder. It comes from building systems that can endure stress. Germany didn't lose the war when Berlin fell. It lost it when the lights went out and there was no way to turn them back on. The collapse of Germany's electrical grid during World War II ultimately reveals a truth that extends far beyond the conflict itself. It shows that wars are not decided only by generals, weapons, or courage, but by the quiet, cumulative behavior of systems that sustain a nation's ability to function. When those systems fail, defeat becomes inevitable long before surrender is signed. Germany entered the war, believing that speed, discipline, and ideological unity could compensate for structural weaknesses. This belief was not accidental. It was rooted in a worldview that equated power with visible force, armies marching, factories producing, cities mobilized. Electricity, by contrast, was invisible. It did not parade through streets or appear in propaganda films. It simply flowed, silently enabling everything else. And because it was invisible, it was taken for granted. That complacency proved fatal. As the war progressed, Germany continued to interpret success and failure through production statistics and battlefield reports, while ignoring the deeper indicators of systemic health. When weapons output temporarily increased under administrative reforms, leaders assumed the crisis had been solved. In reality, the system was being cannibalized. Power plants were aging faster than they could be repaired. Transmission networks were operating without redundancy. Engineers were forced into a permanent state of improvisation, keeping the grid alive through emergency measures that could not last. This pattern illustrates one of the most dangerous illusions in complex systems: the illusion of stability under stress. Systems often appear functional right up until the moment they collapse. Because failures are delayed, decision makers misinterpret warning signs as manageable problems rather than symptoms of terminal overload. Germany's grid did not fail suddenly. It failed progressively, invisibly, and irreversibly. Another critical lesson lies in the relationship between short-term urgency and long-term survival. Germany's leadership repeatedly chose immediate military output over infrastructure investment. These decisions were rational within a narrow time horizon. Tanks today mattered more than power plants tomorrow. But war is not a short-term phenomenon. It is a prolonged stress test. Every decision that sacrifices resilience for speed reduces the margin for error later. Once that margin disappears, events accelerate beyond control. By 1944, Germany was no longer managing a war economy, it was rationing collapse. Electricity was no longer a tool of production but a weapon of triage. Every allocation decision meant condemning one sector to failure in order to temporarily preserve another. These choices were not strategic, they were desperate. And desperation is not a foundation for victory. What makes this lesson especially important is how transferable it is to modern societies. Today's nations rely on electrical systems far more complex and interconnected than those of the 1940s. Digital networks, automated logistics, healthcare systems, financial markets, and food supply chains all depend on continuous, stable power. A failure in the electrical grid today would cascade faster and more comprehensively than anything Germany experienced during the war. And yet, the same vulnerabilities remain. Modern systems are optimized for efficiency, not resilience. Spare capacity is minimized. Redundancy is treated as waste. Infrastructure investment is postponed because its benefits are invisible during normal operation. These are precisely the conditions that made Germany's collapse inevitable once stress exceeded design limits. German experience also demonstrates how authoritarian decision-making accelerates systemic failure. When institutions punish the delivery of bad news, problems do not disappear, they metastasize. Engineers in Germany understood the electrical crisis long before it became public. But acknowledging it openly would have meant confronting ideological assumptions and political authority. Silence became survival, and silence allowed collapse to proceed unchecked. This dynamic is not unique to dictatorships. Any system, corporate, political, or military, that discourages honest reporting of constraints will eventually fail in the same way. Reality does not negotiate. It only accumulates. Perhaps the most sobering lesson of all is this: there is a point beyond which recovery is impossible. Germany crossed that point when its electrical grid lost the ability to sustain continuous industrial activity. After that, even perfect strategy could not have saved the war effort. Defeat was no longer contingent, it was locked in by mathematics. This challenges the comforting belief that determination can always reverse decline. In reality, determination only matters when systems still function within recoverable limits. Once those limits are exceeded, effort accelerates exhaustion rather than recovery. In the end, Germany did not lose World War II solely because of Allied armies advancing on Berlin. It lost because the foundation of its industrial power collapsed beneath it. The blackout that spread across factories, railways, and cities was not merely a symptom of defeat, it was its cause. The final lesson is therefore both simple and unsettling. Power in the modern world is systemic. It does not come from speeches, symbols, or even weapons alone. It comes from infrastructure built patiently, maintained honestly, and respected for its limits. Germany ignored those limits. And when the lights went out, history followed. The implications of this lesson extend even further into how nations understand success while it is still unfolding. Germany's leadership repeatedly mistook activity for capacity. Factories were busy, workers were mobilized, trains were running, so the system was assumed to be strong. But activity is not the same as sustainability. A machine can run at full speed right up until the moment it seizes. This distinction matters because many systems fail not when they are idle, but when they appear most productive. Germany's war economy reached its highest nominal output precisely when its electrical foundation was closest to collapse. That coincidence blinded decision makers. Rising production figures masked the accelerating decay beneath them. The grid was being consumed to create the illusion of strength. Another overlooked lesson is how complexity amplifies fragility. As the war progressed, Germany's economy became more technologically advanced and more interconnected. Jet aircraft, synthetic fuels, advanced submarines, precision weapons all increased dependence on stable electricity. Each technological leap raised the minimum energy threshold required for the system to function at all. In simpler systems, partial failure can be absorbed. In highly complex systems, partial failure becomes total failure. Germany's late war economy had no graceful degradation. When electricity faltered, entire production chains stopped instantly. Complexity, once a strength, became a liability. This is a critical warning for any society that equates technological sophistication with invulnerability. Advanced systems are not inherently resilient. In fact, they are often more brittle unless deliberately designed otherwise. Germany did not build redundancy into its grid because redundancy did not increase immediate output. It increased survival, and survival was undervalued until it was too late. There is also a moral dimension to this story. The electrical collapse exposed the emptiness of the regime's promises. Nazi propaganda glorified sacrifice, endurance, and obedience. Yet the system it built could not sustain the population or the war effort. Civilians endured blackouts, freezing homes, halted transport, and failing hospitals not because of enemy occupation, but because the state had exhausted its own foundations. When infrastructure fails, it does not fail selectively. It punishes soldiers and civilians alike. It erases the boundary between front and home front. Germany's electrical collapse turned every city into a battlefield, every factory into a liability, every winter night into a threat. In that sense, the grid did not merely support the war, it defined its limits. The final months of the war reveal the ultimate consequence of systemic failure: loss of agency. By 1945, Germany was no longer choosing its actions, it was reacting. Decisions were driven by shortages rather than strategy. Operations were planned around what little power remained rather than what was militarily optimal. This is the hallmark of collapse, when systems dictate choices instead of leaders. At that stage, even surrender became inevitable. Not because of moral awakening or political realization, but because the state could no longer function. A nation without electricity cannot communicate, coordinate, or command. Defeat was embedded in the infrastructure. Looking back, it becomes clear that Germany's greatest miscalculation was not tactical or even strategic, it was systemic. The regime believed war was a contest of will. The Allies understood it as a contest of systems. One side pushed harder, the other built deeper. And depth wins. The enduring lesson is not that Germany should have built more power plants instead of tanks. It is that power itself must be understood correctly. True power lies in the capacity to sustain effort over time, to absorb shocks, to repair faster than damage accumulates, and to operate within physical limits rather than denying them. History did not punish Germany for lacking ambition. It punished Germany for ignoring reality. When the lights went out, the war was already over. The collapse of Germany's electrical grid during World War II ultimately forces us to reconsider how power is defined, measured, and misunderstood in modern societies. The Reich did not fail because it lacked ambition or technological skill. On the contrary, it possessed some of the most advanced engineers, scientists, and industrial planners of its time. What it lacked was a correct understanding of how systems behave under prolonged stress. Germany treated electricity as a supporting detail of war rather than its foundation. That misjudgment shaped every major decision that followed. At the heart of the problem was a confusion between mobilization and capacity. Mobilization is the act of activating resources, workers, factories, raw materials. Capacity is the ability to sustain that activation without collapse. Germany excelled at mobilization. It failed catastrophically at capacity planning. The electrical grid became the clearest manifestation of this failure because it was both indispensable and finite. In the early years of the war, the grid's endurance created a dangerous illusion. Power plants continued to function despite overload. Engineers compensated through skill and improvisation. Breakdowns were repaired just quickly enough to avoid public acknowledgement of crisis. This fostered the belief that the system could always be pushed further. What leaders failed to grasp was that every emergency fix consumed future stability. This is a recurring pattern in human systems. Temporary solutions are mistaken for permanent ones. Short-term survival is confused with long-term viability. Germany's grid survived early overloads not because it was strong enough, but because it had not yet exhausted its accumulated reserves of reliability. Once those reserves were gone, collapse accelerated. Another lesson lies in how invisible constraints are systematically undervalued. Weapons output could be counted. Soldiers could be paraded. Factories could be photographed. Electricity could not. Its importance was assumed rather than measured in strategic terms. As a result, electrical capacity never received the political protection granted to more visible elements of the war effort. This invisibility had consequences. When resources became scarce, electricity lost every internal competition. Steel went to tanks instead of turbines. Copper went to ammunition instead of transmission lines. Skilled labor went to weapons plants instead of power stations. Each decision seemed logical in isolation. Collectively, they dismantled the foundation of production itself. Germany's leaders did not destroy their grid deliberately. They dismantled it by neglect. The electrical crisis also highlights a critical distinction between local success and systemic failure. Individual factories sometimes exceeded production targets even late in the war. These successes were celebrated as proof of resilience, but they masked the reality that the system as a whole was deteriorating. When power was diverted to one facility, it was removed from another. Gains were zero-sum. The system was cannibalizing itself. This fragmentation explains why late-war German production often appeared impressive on paper while collapsing in practice. Weapons were completed without fuel to operate them. Vehicles were assembled without transport networks to deploy them. Aircraft rolled off lines without trained pilots or reliable power for maintenance. The grid's failure turned industrial output into unusable artifacts. In this sense, Germany did not simply lose capacity, it lost coherence. The war economy stopped functioning as an integrated system and became a collection of isolated efforts competing for diminishing resources. Another profound lesson is the role of time in systemic collapse. Infrastructure operates on long timelines. Power plants are built over years. Transmission networks evolve over decades. War compresses time violently. Decisions that would be manageable in peacetime become irreversible under combat conditions. Germany entered the war without having invested sufficiently in future electrical capacity. Once fighting began, the opportunity to correct that mistake vanished. Bombing, resource diversion, and labor shortages made long-term infrastructure projects impossible. The system became trapped by its own history. This demonstrates a critical principle. Infrastructure decisions must precede crises. They cannot be improvised once stress begins. Nations that delay such investments do not merely risk inefficiency, they risk strategic paralysis. The electrical collapse also reveals how centralization increases vulnerability. Germany's grid was regionally concentrated around industrial hubs like the Ruhr. This concentration increased efficiency but reduced survivability. When Allied bombing struck these nodes, the effects radiated outward instantly. Decentralized systems degrade more slowly. Centralized systems fail more dramatically. Germany chose centralization because it maximized output under normal conditions. War punished that choice ruthlessly. Equally important is the lesson about feedback suppression. Engineers understood the danger. Mid-level administrators understood it. But information flows upward only when institutions permit it. Germany's political culture punished those who reported unsolvable problems. As a result, warnings remained fragmented and muted. This is not merely a moral failure, it is a mechanical one. Systems rely on feedback to self-correct. When feedback is blocked, systems drift toward collapse without resistance. Germany's grid did not fail suddenly. It failed because corrective signals were ignored until correction was no longer possible. The war also exposes a deeper misconception about technological superiority. Germany believed that advanced weapons could compensate for material and infrastructural deficits. This belief persists in many modern strategic cultures. But advanced technology raises baseline requirements. It increases dependence on stable power, precision manufacturing, and logistical continuity. Germany's